We know that the humans already changed the climate of the planet. All the historical records that humans have about climate, you don't have the highest levels of CO2 we have today. So either we want it or not, we already changed the climate of the planet. To really understand the significance of this, we really need to go back into the geological record, because that's when you see those similar changes taking place. So geology now, I think, is a really key to understand the future. About 6 years ago, Panama decided to expand the Panama Canal. And for us was a unique opportunity, because you work in the tropics, you realize that most of the landscape is covered with rainforest. Panama is in a unique location because it's a small piece of land that is connected to large continents, South America and North America. So all the rocks you see exposed here was giving us a window in time to the first events that led to the development of the landscape we have in Panama today. We knew we only have 5-6 years to accomplish everything we wanted, because the excavation was happening really fast. So we put together a large team from the Smithsonian, together with many specialists in different fossil groups and different geological techniques. We put everything together, all the data from the fossils, from the geology, from all the chemical analysis we have done here. We realized that the history of the rise of the isthmus was more complex than we thought before. Once a land that used to be an ocean was, for the first time, you will see landscapes. So if you're in the ocean, the rise of the isthmus was an experiment to split population. If you are in land, it's the opposite process. Things that were separated, now they are joined together. So animals and plants start to moving from the north to the south, to the south to the north. Once the isthmus is up, this thermohaline circulation that is also called the conveyor belt, that is a process that happens in the ocean that is a major component of our climate today. This thermohaline circulation originates because the isthmus is up and the Caribbean water is not connected to the Pacific waters anymore. So here we have learned how sensitive tropical ecosystems are to minor changes, and by learning the geology of them and the geological history of past ecosystems, we think we can understand or help to understand what will happen to many tropical ecosystems in the near future.